We've looked at how we can obtain the kinematic equations using other equations. We're now going to look at how we can derive one of the kinematic equations using a graph. Here we have a graph, velocity time graph, of an object that's starting with velocity u, finishing with velocity v. Now, if I work out what the area under this graph is equal to, the easiest way to do it is to split it into two areas. Then the first area is just the area of the rectangle, which is u times t. And the second area is the area of the triangle, which is half the base times the height, which is a half at. So a half at squared. If we substitute those in, the area under the graph is ut plus a half at squared. Now that is the equation for displacement. So if we've got a velocity time graph, then we can either calculate the displacement using an equation, or we can simply work out the area under a velocity time graph. And that's true for uniform accelerations. And we can also do it for non-uniform accelerations as well, but only using the graph. The equations don't work for non-uniform acceleration. So, let's summarise by looking at all the kinematic equations we've discovered. We have v is u plus at, s is u plus v over 2 multiplied by t, v squared is u squared plus 2as, and s is ut plus a half at squared. You will need to know these equations, and it's worth learning them by heart so that when you're given a SUVAT equation question, you can simply pull one of these equations out of your mind and answer the question. And we're now going to have a look at how exactly we should use these equations to work out things about a moving object.